So I will be posting this test hopefully tomorrow, and then it will be open for a long time, like about 2 weeks, so that you can kind of decide what, like some people are really caught up and they're like, no, I'm ready to take the test, so I want to make it available to them. Others like, no, I need the Thanksgiving break to make sure I can get caught up, and so the test will be open starting hopefully tomorrow through like a few days after Thanksgiving break. So. Yeah, it's at home because we keep losing class times. Okay. So hold on, I lost something. 1 second. Here we go. I just need a volunteer who's willing to talk with me, and then I'll decide if you said enough to earn a ticket or not. So just someone who's willing to talk. So let's go, Isaac. Okay, so it says f is a differentiable function. It then gives a bunch of clues, which I honestly, the first time I read this problem, I didn't really have any idea as to what I was supposed to do with all these clues because they're kind of random. They're not anything that I've seen before that brings any sort of memory. So just keep reading. It then gives this clue. Okay, this clue does trigger a memory. That one triggers a flashcard memory. If Isaac can remember the flashcard memory that I am having, I will pay him a full ticket.
Like one of your motto things? Or?
Oh, good question. This one's not a motto. This one's actually a formula that you have that I'm going to maybe have on a flashcard so I make sure I never forget it.
Yeah, I was going to say, for that, you can use the derivative for the inverse function.
There we go. No, it's perfect, Isaac. So on my flashcard, I would have this. And then on the other side of the flashcard, what do I have, Isaac?
The answer, which is 1 over f prime parentheses f. I did it first. X. Said that wrong, but.
You did okay. So that's, when I see this in blue, I've never seen an AP problem that gave me that clue that didn't end up requiring this knowledge. So I want to make sure I have a flashcard that says that so my memory will be triggered when I'm taking the test. Questions? Cool. So this is where like I've been stressing good notation all year long. This problem is a perfect example of where good notation will lead you to the answer. Bad notation, you'll be just frustrated. You won't be able to find the answer. They want me to find G prime of 3.
Kaylee Wolfton and Jackson Miller, please come to the front office.
Okay, look. Someone else can earn a ticket now. Wait for Ellie to stop laughing. There we go. Sorry, recording
We were
off.
just talking about it.
Well, you know. No talking. Someone else who'd like a full ticket. Raise your hand and tell me, what is another way to write, like another notation, where notation is so important. What's another way to notationally indicate G prime of 3? There's another symbol you've all learned. You've seen me do it on the board more than once. That symbol means the same thing as G prime of 3. Full ticket available. David?
D of y3 over dx.
Close, 2 points. Maggie?
The dg3 over dx?
Say again.
dg3 over dx?
Let's put the two of them together. 2 points for Maggie. Maggie and David are still eligible for a ticket here in a minute. We want to find the derivative of g. Now, you can't put a 3 here. If I put a 3 here, that means to put a 3 into g first and then take a derivative. I don't want to do that. I want to take a derivative of g, then plug in 3. So I put a bar, which means I'm going to find the derivative of g first, then I'm going to plug in x equal 3. Okay? Look up. Next step is also huge, meaning it's going to happen over and over again throughout the year. You need to get very good at substituting, meaning recognizing when two things are the same, you can unplug one of them, plug something else in. So that's what I want to write on the next line. I want to take advantage of substitution to write this in a slightly different way. Like I want to take something out, put something in its place. David's going for the ticket again.
D of 1 over f prime, then the parenthesis f to the negative 1 x over dx, and then the bar, and then x equals 3.
Okay, so here's the 2 more points. Here's the mistake you made. You said I should put in place of this d of this, right?
Yes, over dx, and then
Gotcha. But there's nothing on the page that says, there's nothing on the page, there's nothing in any of my rule sheets, in my flashcards that says d of that is the same as d of this. So
well,
I
it
can't-
said g of x equals that up there, right? So can you replace g of x with?
Stay with me. Say what you just said.
It says g of x equals f to the negative 1 of x, right? And so and then that thing on the bottom there.
Ignore this for a minute. You were heading the right place a minute ago. You said
Yeah.
g of x is the same as this, therefore,
Yeah, we can replace g of x with f to the negative 1 of x.
perfect, perfect. These two are the same. So anywhere I see g of x, I can replace g of x with f inverse. That's totally valid. That doesn't say that this is the same as that. You see what I'm talking about?
But isn't f inverse of x the same as 1 over f prime?
Close, close, close. Stay with me, you're earning the ticket. So the first substitution I'm hoping you all see is pretty easy. Right here, g of x is the same thing as this. So on my next line on the paper, I'm going to write d of f inverse. Because f inverse and g are identical. So the blue right here is exactly the same thing as this. Okay, does anyone need me to talk more about that? You have to see it. If you can't see it, you got to talk about it. Those are the same because they said g and f inverse are the same. So they're wanting me to find this one. All I'm doing is stringing together a bunch of equal signs. Okay? But what I was trying to say to David is this is not this. There's nothing on the board that says these two green boxes are the same.
Oh, that's not what I was trying to say.
Oh,
I was trying to say you replace, I was trying to say, you know how you replace d of dgx with df negative 1x? Just take that f1 of x and do 1 over f prime.
oh, there we
and
go.
C. That's what I was trying to say from the start.
Now we get it. So now we can do this because of the formula.
Yeah, that's what I was going for from the start.
There
I
we
think we
go.
had a miscommunication.
No worries.
I was very confused.
Okay, anyone want to talk about that? Everybody good? Not good, talk about it. Watching the pencil so it doesn't go faster than you can write. Please,
Well, I just going forward with it.
keep going, talk.
Want the reciprocal be negative 1/3? Would you do that, or is that?
Hold on, you're still eligible for a ticket here, stay with me.
Attention, new teachers, please head to the media center.
So there's a problem with the word inverse in the mathematical world. Sometimes we say the inverse of 3 is 1 over 3. and that's valid. But when we say F inverse, that's not what we're talking about. So F inverse means something else. So stay with me. Do you happen to remember, Logan, what F inverse of 3 means? And if you don't, saying no is fine. What's that? No is a very valid answer. So you're going to help me build some memory here. That's something you've done before, you just have forgotten. There are clues up there in green, right here. I want to put those clues into a table form. So I want to build a table for F, not F inverse, for F. So Logan, based on the clues they gave you in green up here, what numbers can I put into this table for F?
When x equals 3, f x equals 15.
Keep going.
When x equals 6, f x equals 3.
Okay, so we need help with that. Focus, don't talk. Cool. So now I'm hoping that you'll remember how to build this table, Logan. But if your answer is I don't remember, that's still valid.
Would it be 3 for x and then negative 115?
Good guess, actually, but no, it's okay. Let's go to Mike in the back.
Is it 15 for x and 3 for the inverse f?
Keep going, Mike.
And then 3 is the x and 6 is the inverse f?
Yeah, that's what F inverse means. Stay with me, Mike, so you can understand it as well. So now you have a table for F, and you also have a table for F inverse. So Mike, you kind of joined us late, but we're right here on the purple. Our goal was to find, as it says right here, G prime of 3. And we've strung together a bunch of equal signs. So now we're here, which means we're trying to identify F inverse of 3. So Mike, can you look at the board and tell me what F inverse of 3 is?
So is it 15? Or is it 3? Oh wait, no, it's 6, my bad.
There we go. It says right here, when you plug a 3 into F inverse, the value for F inverse is 6. So F inverse of 3 is 6. So that means I could rewrite this as what? Just tell me exactly what to write, Mike. So I'm rewriting this with my new knowledge. So you're making it
So
hard.
it'd be
Go ahead.
F prime and then in parentheses 6?
Yeah, just don't forget the 1.
Or 1 over f prime in parentheses 6?
There we go. It's all about substitution. All you're doing is recognizing that this has a value of 6, therefore I can take that out and put in its place 6. So can you look at the board, Mike, and tell me the value for f prime of 6?
Negative 2.
Questions? Nicely done. Questions, please.
I don't know if it's powered, like, it makes sense powered, no, like, could we found, did we just find F inverse again?
So what we found was G prime of 3.
How?
So,
Because of like the X equals 3 thing?
really, to me it is very mysterious how we found G prime of 3.
Because I thought we just found the F inverse.
No, we found G prime of 3. We just did it little by little by stringing together things that are equal to each other. And so this is a good example of how what comes out at the end doesn't seem to really have any connection to what we started with. but we didn't violate any math rules, and we made sure we always used equality, so we're okay. But it's crucial that you can follow it, so let's go through it real quick. So are you comfortable, Cambria, that they wanted us to find G prime of 3? Awesome. Are you comfortable, now this part you do have to just pull out of your head, that G prime of 3 means exactly the same thing as finding the derivative of G first, and then once G, the derivative of G is found, you're going to plug into that 3. So you're good there.
And that's when you get
Not exactly. That's when we say, oh, they told me that these two are the same, so let's stop looking for G prime. Let's go looking for the derivative of F inverse instead, because they are the same. Now you're okay. Good. It's funny how traditions last for years and years.
Wait, did you used to do this
Oh,
in
yeah.
first grade too?
Like 50 years ago.
Dude, it's so.
I just think it's funny, right?
I love that.
I'm so much older than all of you, and we all did this too.
We all do it.
Oh, yeah.
Well, it's so cool. How does it do that?
It's just because your eye can't track fast enough. It's the same thing as, no, let's stop the video.